Let us draw a circle, and let's also draw a square so that its left side is touching the outer line of the circle and its upright and downright corners are also touching the outer line of the circle. Let's say that the distance between the right side of our square and the farthest right point of the circle is equal to 2. Can you calculate the area of this red circle? If you want to try this problem for yourself, this would be a great time to pause the video and do so. Alright, let's get to the solution. Let us first draw the diameter of the circle and let's mark the center of the circle. Now we will mark the radius of the circle as r and we will mark the side of our square as a. Since the radius of the circle is also located from the right of the center of the circle, we can conclude that the distance between the center of the circle and the right side of our square must be equal to r minus 2. Now we can use this to form our first equation. We can see that the side of the square a must be equal to the sum of the radius of our circle and this yellow segment of r minus 2. So that means that a must be equal to 2r minus 2, and we can see that 2 is a common factor, so we can simplify this as 2 times r minus 1. This would be our first equation. Now let's try to find another one. Now let's draw a line from the center of the circle to the intersection point of the upper right corner of the square and the outer line of the circle. This will also be the radius of our circle. We can see that this line forms the right triangle that has the hypotenuse r, the down leg of r minus 2, and the right leg will be equal to the half of the side of the square, so that is a over 2. We can isolate this triangle and we will notice that since it's the right triangle, we can apply the Pythagorean theorem. So the square of hypotenuse, in our case that is r squared, must be equal to the sum of the square of its legs. In our case that is r minus 2 squared plus a over 2 squared. And this is our second equation. Now we can substitute the value of a from our first equation into our second equation and we will get the following. Now we can simplify the last term by cancelling 2 in the denominator and the numerator, and we will get that r squared is equal to r minus 2 squared plus r minus 1 squared. Now we can see that these two terms represent the square of binomial. Just to remind you, the formula for square of binomial states that a minus b squared is equal to a squared minus 2ab plus b squared. So we can use this formula to develop our two terms. So r squared will be equal to r squared minus 4r plus 4, and if we develop the second term, that would be r squared minus 2r plus 1. Now we will simplify our equation by cancelling r squared on the left and on the right side of the equation, and if we group the common terms together, we will get the following equation of r squared minus 6r plus 5 that is equal to 0. As you can see, this is classical quadratic equation. We can use numerous ways to solve the quadratic equation, but for this video I will use the method of splitting the middle term. That means that we can substitute the value of our middle term of minus 6r for the values of minus r minus 5r. This way we will first take a look at the first two terms. Since they have the common factor of r, we can simplify them as r times r minus 1. Now if we take a look at the last two terms, we can see that they have the common factor of minus 5, so we can simplify them as minus 5 times r minus 1, and of course that is equal to 0. Now we can see that our new two terms have the common factor of r minus 1, so we can simplify this as r minus 1 times r minus 5, that is equal to 0. From here we have two possible solutions. The first one will be that the factor of r minus 1 is equal to 0, and that means that r is equal to 1, And the second one is that the factor of r minus 5 is equal to 0, and that means that r is equal to 5. But we will notice that since the distance between the center of our circle and the right side of our square is equal to r minus 2, that means that r cannot be equal to 1. We can also see this if we substitute the value of r in the equation for the side of our square. We will get that is 2 times 1 minus 1, and that is of course equal to 0. This is mathematically impossible because the side of the square cannot be equal to 0. That means that we can easily disregard this solution. So the only possible solution is that the radius of our circle is equal to 5. Now it is easy for us to find the area of the circle using the formula r squared pi. That would be 5 squared pi, and we will get that the area of our red circle is equal to 25 pi, and this is our solution. Hope you guys enjoyed this video. If you did, smash the like button and subscribe to the channel for more content. And until next time, see you guys and take care.